Thank you all for coming to join us on a slightly chilly December evening. It's not too bad for this time of year. We're delighted that you've joined us, and we're delighted to be able to give you an update on the UKMS Register this year and Octopus for 2024. We've got 3 talks today from 2 excellent speakers and me, unfortunately, and are delighted to be joined by Professor Richard Nicholas and Professor Jeremy Chataway. Dr. Nicholas is clinical lead of the UKMS Register and a consultant neurologist at Imperial College London, and Dr. Chataway is a consultant neurologist at University College London and chief investigator of the Octopus study. I'm going to start by telling you what the Register has been up to over the last year. I'm Rod Middleton, I'm the PI of the UKMS Register. Some of you will know me. Professor Nicholas is going to have a talk on what have we done with your data, and then Professor Chataway is going to talk about optimal clinical trials platform for progressive multiple sclerosis. We have done one of these before in 2023, and we're going to try and make these more regular, so hopefully you'll enjoy them and learn something and ask us sensible questions and useful questions that you can elicit more information about the Register as we go through it. So today I'm going to talk about what the UKMS Register's achievements have been in 2024. We're going to try and address some of your most commonly asked questions that we actually, that you ask us when we're out and about or we get into the inbox on the Register, and talk a little bit about what's coming up in 2025. So achievements in 2024, new joiners, so all of our new participants that have signed up clinically or via the portal, welcome and thank you very much. We've had 766 new registrations via the web portal this year. 617 people have signed up at NHS hospitals, and we welcome 4 new NHS sites. So maybe these are one of your sites that have joined now as well. So Coventry and Warwickshire, North Cumbria Integrated Care Trust, Broomfield and Conquest Hospital have all joined us. That's good, but what does that mean in context? And I did think about long and hard whether I was going to put up lots of tables and numbers and things for you, but I'm not going to do that. Instead, I'm going to encourage you to scan the QR code. Well, this presentation will be available afterwards, or you can visit that URL. And there is what I'm scrolling through in the background, effectively. All the facts and figures of the UKMS Register over the last 5 years. Well, up to 2023. We'll update it again at the end of this year. And there you will find lots of information about ethnicity, what treatments people are on, what symptoms people are experiencing, the differences between the portal and the clinical populations, as I'm scrolling past it now. Age of onset, all that kind of stuff is available there for you to go through at your leisure, really, to understand how things change year on year, should you choose to do so. So that's probably the best way to go and get a general overview of what's going on with the Register, if you've got time to do that. If not, I'm going to give you a little update now, but that's always there for you. And like I say, we'll update that in 2024 as well. So sorry if that flipped by a little bit quick, but you can consume it at your leisure. I want to talk a little bit about counting people on the Register, because if you've been with us for a while, and thank you to those, I think it's 574 participants that have been with us for the last 13 years and have answered everything at every single point we've asked. And thank you to any of you that put in any amount of data at any point. But the way we count people in the Register is quite important to understand. As of December 2024, we have 33,607 registrations. That's not a number we'll talk about an awful lot, and I'll explain why now. A registration is not the same as having enough data on a person to actually be able to count them within the research. So if we look at how many people have actually got complete demographics, and by that I mean surname, forename, date of birth, postcode, possibly NHS number, and your ethnicity details, that takes that 33,000 down to 20,106. So lots of people never actually complete the registration all the way through. So that's the first point at which the number goes down. We then look at valid dates, and by a valid date, I mean a date of birth followed by an onset date, followed by a diagnosis date, i.e. a diagnosis date can't become before an onset date. That number goes down to 19,843. Just a small drop this time, but there is a slight effect on that with dates. This is something we've fixed in later versions of the Register, that you can't enter incorrect dates, but it's just something to be aware of for how we do the counting of the numbers. And lastly, 17,300 plus people who've completed a questionnaire. So most people complete more than one questionnaire, and lots of people are with us for a few years or longer, but have also completed a questionnaire. So that's sometimes, if you look at some of the data we put out, the number at the top, the big N number that we put out, can change depending on how you cut this data and what it is that you're looking for within that. So I hope that's helpful in understanding where we get to where we get to. In comparing questionnaires answered on the portal between 2023 and 2024, initially 2024 looks down, but I'll explain why that's kind of expected. In 2023, you, our participants, completed 94,173 complete questionnaires for the core things that we ask: MSIS score, fatigue severity scale, hospital anxiety depression scale, all those questionnaires that you get every 6 months, 59,000 of those. However, we did better in 2024 with 65,712 answered. 10,528 web EDSSs in 2023 versus 11,554 in 2024, slightly more. The disparity between these things is in 2023, we get 23,770 guest questionnaires were answered, and we haven't asked that many guest questionnaires thus far in 2024. That's about to change. I'm going to talk about the lifestyle questionnaires we're about to put out, but at this point, we've only asked 5,072 guest questionnaires. So that's that. But I suspect by the end of 2024, we'll actually have more responses in 2024 than we did in 2023. Turning to the research that we've carried out just in 2024. So this is publications in peer-reviewed journals, which is how we sort of build on the science that the register has been doing. And over the years, we've published over 70 papers at this point altogether from UKM's registered data. But in 2024, we've looked at algorithms to identify MS and routine data. So that's data from the Welsh NHS, or for example, the English NHS, the same algorithm could be applied. The relationship between ethnicity and MS, barriers to medication adherence, i.e. remembering to take your tablets, for example, was part of that paper. We've had one paper looking at diet, and I'll come back to that in a minute. We've worked as part of the Global Patient-Reported Outcomes Initiative, so that's not just the UK, that's Italy and America and Denmark and Germany and lots of other countries as well. We've looked at measuring fatigue and multiple sclerosis. Something we've published extensively on is measuring fatigue and multiple sclerosis. We've looked at how having a university education can affect access to disease-modifying therapies. We've looked at initiation patterns of disease-modifying therapies in the UK, the US, and Germany, and that's how the systems differ between the countries in order to be able to gain access to disease-modifying therapies. And we've looked at MS care and its integration of how these new therapies are prescribed versus holistic management, i.e. treating you as a whole person in comparison to the quite technical means of getting and receiving prescriptions. So quite a lot of papers in quite important subject areas over the last year. We've also been working extensively with Octopus, and Professor Chataway will cover that in far more detail than I'm about to, but we've helped with the registration of interest for the multi-arm, multi-stage trial that is Octopus. The first stage, and Jeremy will go into this more detail now, is recruited at 375 participants, but the second stage needs 825 participants, and that's starting early next year. So this is not over. This is just beginning. So we appreciate your patience and how long sometimes it's taken to find out information about Octopus and where you are within that. But stick with us. More is coming on that. So, and Jeremy will go into that in more detail. Turning to the second part of this, I just want to cover some of your frequently asked questions, like I say, that we get when we're out and about in person or that we get by email. The first question we get is, can you tell us more about symptoms? What other symptoms are people experiencing? So I'm very quickly just going to point this out. These are all the symptoms we record in the UKMS register. This particular table was decided in collaboration with people with MS and neurologists and other academics. They're the reason we ask the symptoms we do. If you note, the scale goes up to 15,000. People can report more than one symptom, so that's a factor as well. But by far and away, our most reported symptom is fatigue. But all of these other symptoms, as we scroll along here, are reported in the thousands. So ataxia and nystagmus aren't as highly reported as fatigue, but thousands of people still experience them. So the point of this is that you're not alone in experiencing these symptoms, and all of this matters. And we will do more in the future to carry out more research on this for how many symptoms do people experience in parallel, the severity of them, and all other aspects like that. So it's just to make you aware that that's ongoing. We've heard a lot this year that we don't ask enough about lifestyle. So I just want to talk about that in a bit more detail. So it's an area of interest for us too. We have carried out previous research on diet. So we published a paper in 2021 with colleagues at Oxford Brookes University using an instrument called the Food Frequency Questionnaire. And we've repeated that recently as well. So more research will be coming on diet soon. This year, we had a methodology paper that we published with Oxford Brookes and with Melbourne University in Australia, looking at methodologies to be able to compare diets around the world, and hopefully something more, a publication on diet, particularly around the Mediterranean diet, will be coming fairly soon. In 2021, we published data on smoking and the impact of stopping smoking on your MS. We've talked about this before, so I won't dwell on this slide, but effectively stopping smoking is one of the best things you can do to take responsibility and management of your own condition. And that improves your mood and it improves your physical ability. So it's absolutely worth stopping smoking if you're continuing to do so, and it's never too late is kind of the message to that, to give up smoking. So that was an important thing and obviously a lifestyle factor that we researched. We have 2 ongoing studies at the moment. We have the UK MS Pregnancy Register and a menopause questionnaire, which is currently live on the register, both run by Professor Ruth Dobson. The Pregnancy Register, which only launched 3 years ago, has 301 participants, and the menopause questionnaire, as of this morning, has 2,153 responses. So they're live now. So we are beginning to try and do a better job of capturing more aspects of MS, factors affecting MS within the population. The last question I want to turn to, and this is a slightly more complicated topic, but I will hopefully make it make sense to you, is what do we do with your data? How do we manage and allow access to the data that we capture? There are 2 means of getting onto the UKMS register. You consent at your clinical centre, sign your consent form, agree to us all the terms and conditions of that, and at that point we're able to have access to data. Or you sign up on the portal, you give us access, you agree to the terms and conditions, and that's it. Or what we really want to happen is both things. You give clinical consent and you join the portal. What happens next is that we take that data, and it's important to understand that we are bound by a bunch of laws and good practice for the way that we manage, look after, and work with your data. So we need to have National Research Ethics Service approval. So that's an NHS body that looks at ethics to make sure what we're doing is ethical. We need research governance sponsorship from our institutions to make sure that we're doing the right thing by that data and for those ethics. We need to abide by the GDPR, the General Data Protection Regulation, which is a European law that governs, that gives rules about how we look after your data and how we can manage it, and the UK Data Protection Act from 2018. So that's the law, the framework in which we work. Data is securely transmitted to Swansea University, which you can think of as being behind firewalls and all that security type stuff in a database, but I just want to zoom into that a little bit. When the data arrives, we split it into 2 parts effectively. Your identifiable data, your demographics that I talked about before, is anonymized. So we remove anything identifiable from that in terms of your surname, your forename, your date of birth becomes a week of birth, or more often just a year of birth. Any location identity is abstracted away from as well. We never release postcodes. And ethnicity becomes standard categories within that. So we remove anything potentially identifiable from that. And if you live in a particularly remote part of the country, the location identifier is abstracted away again even further. So not even down to an area level within a town, but a town or a county or further out, depending on how busy it is in the county in which you live, the area in which you live. The second part of that is your clinical or your questionnaire responses, which are separated from, are parsed for free text or any other potential other identifiers to ensure that there's nothing in there. And free text can quite often, if people are writing to tell us stuff, can contain identifiable information. So that's all removed as well. So that's how the data is treated. And all of that goes into an anonymized database, which we don't even work on. Your identity is used purely for linkage for other sources, so portal to clinical, clinical to portal, then removed, or for us emailing or getting in touch with you for things like this webinar, or to ask you to come back and complete your questionnaires. That's what the identity is for. What happens next? Because the next part of this is, it's not just us that work with the data, we allow appropriately qualified researcher to have access to it as well. So if a researcher wants access to the data, they complete the access request process. That application is reviewed by the UKMS Register Scientific Steering Committee, which is made up of some UK neurologists, some representatives of other MS registers from around the world, people with MS, and representatives from the MS Society. I sit on that, but don't get a vote. Incoming research is examined for whether it's appropriate, ethical. There's a good scientific question there. They've got good participant engagement. It's of interest to the community, if it's novel, all sorts of things like that. And should it be approved, and they aren't all, then, and some of this checking does happen beforehand, we ensure that the researcher is not a representative of a for-profit organization, a pharmaceutical company or an insurance company. They've completed MRC safe researcher training. They're a bona fide researcher at a university or an NHS hospital. They have given us a CV with evidence of recent publications, so they know what they're doing. They're trained in the use of our tools that we have to access the data, and they install appropriate software and two-factor authentication credentials on their devices. At that point, we then deploy a project-specific data set, so only the data they need in order to carry out their research, not all of it. And remember, this is from the anonymized data set in the first place. That project-specific data set is deployed to our SERP, our Secure E-Research platform, and the researcher at that point is given access for a set period of time to just that data set. And that's how it works. All of this is maintained within a secure environment. If you're interested, at ISO 27001, which is the highest international security standard for data management, governance, and protection of data. So that's how the widget works, really. Moving on from 2024 to 2025, hopefully tomorrow morning, or certainly by the end of the week, more lifestyle questionnaires will be made available. We're going to ask about sleep, bladder, bowels, interest in sex, exercise, culture, and socialization. So look out for those and we'll email you. We'll soon be emailing you your 2024 research wrap-up. We did this at the end of 2023 as well. So abstracts or papers that your data has gone into, we will tell you exactly which ones they are. We're going to have publications on diet and cognition. More on that from Richard in a minute. We're going to have more engagement. So if this is successful, hopefully more webinars and data from the register to you. And we're going to work with resources like Consensor to provide more information on clinical trials and other research that you may be eligible for, because that's something we hear about a lot as well. And at that point, I just want to say thank you very much. The register is nothing without you. And thank you to the MS Society, who remain our primary funders in the UK MS register, and we couldn't work without them and you. So thank you very much for that.
Thanks, everybody. And what I'm here to do today is to sort of tell you a little bit about what we've actually done with your data, and try and go a little bit into some of it. It's all a bit complicated, but just a sec, get this used to move. So just first of all to say that I always like to show my conflict. So I do work in NICE. If you have any questions about that, I also work for the MS Register, and I work for the MS and the PD Tissue Bank, and I've done some work with some commercial organizations, and it's going to talk to really about, this is what the register does, is it digitally monitors MS, and there's benefits and issues with that. One is it makes it more accessible. This is why I think it's been so successful. It's reliable. So in terms of us as in terms of clinicians, the information is usually completed by the same user, so therefore it's quite reliable. And we're trying to integrate gradually increasing numbers of objective assessments. So Rod has talked about all that we collect, which are patient-reported outcomes, but the question is we can also start to collect other outcomes. However, there's some issues with that. Sometimes your disability may impact how you can engage, fatigue, ataxia, unsteadiness, a number of other factors. Also, there's issues about IT access and cost issues getting to it. And also, we don't know who completes it. And in terms of doing trials, no, we don't have a clinical assessment, so it becomes more difficult to validate it. And also, there's another technical issue that the data is sparse. So when you complete data for a couple of questionnaires or miss one out, then the data is not complete. So people in trials like complete data. This is just to say, this is Swansea Bay, where the register is based. On the right is a map of all the people on it. Obviously started 2011, and Rod has mentioned the two ways you can be part of this. So we measure these outcome measures. There's clinical measures and patient-reported measures, which are gradually increasing. And now we've got 13 years of data, which is massive, and about 1 million completed instruments. So an awful lot of data. So that's really, really good. So the trouble is, what we want to do is to make these registries useful for the future. So one thing is to make patient-reported outcomes suitable for use in trials. So the ultimately idea is, could we move this off, move some trials from going face-to-face and allow people to take part online? This would save travel, expense on everyone's part, and also move away from expensive tests like MRI scan that may not give us all the data we want. We've done some cognitive testing, which moves us towards that, which I'm going to talk about in more detail. And also, we've been starting to support drug regulation and health technology assessment, which is basically the regulators in the UK. So this is some work that Jeff did on the right. And what he did is try to compare patient-reported outcomes, where a patient-reported outcome is where someone answers questions about aspects of their own health to capture wider aspects of the impact of, say, MS, but a number of conditions. And the clinical examination score is an examination of someone. As you can probably imagine, these are not the same thing. They don't measure the same thing. And what we do is we did two comparisons, which are one is here. So this is how we compare data in MS. We asked how long it takes for people to get worse over time. And here we compared a clinical measure, so the examination, with a web measure, which is the web EDSS. So you measure it over the computer, and the MSIS-29. And we see confirmed worsening, which we use in trials, and confirmed improvement are exactly the same. So from our point of view, this work is being developed. And then this is it using a patient-reported outcome over the computer and directly face-to-face. So in the MS Smart trial, people completed the data as they were sitting there with the clinician, whereas here they've done it on the blue on the UK MS register, and it looks exactly the same. So this work is still ongoing. So though this looks good, they require further data to improve this. So we're sort of still working on this. So then when we move to cognitive testing, we're actually moving beyond patient-reported outcomes. Though you do it online, these are formal tests of cognition. And I want to thank everyone who's done them, because they're quite testing, quite annoying at times, frankly. So one of the advantages of the computer testing, so face-to-face, you sit in front of someone, you have to get to them, they have to spend their time, you have to spend your time. Symptoms such as fatigue impact it, but you get one answer to each test. Whereas when you do this online, you get a number of answers. As you move through the test, you get lots of outputs from that. And it's also a lot easier to take part. So it means there's wider participation. So one of the things about cognitive impairment MS is it's actually very widespread. It's present throughout the condition, all stages, all subtypes. It really has an impact on quality of life and employment. A number of areas are effective, and it seems to present early on and go on silently for a number of years. So Anna Laura did this work, and what she did from the online is, again, it's scalable. So in person, it's not scalable, it's not cost effective, it's not time effective, but it might be sensitive and standardizable. But online, we can do this, and we have something called the Cognitron, which was built by Adam, Hampshire. And it's got about 400,000 or 500,000 people. It's very low cost. We've got lots of time points, lots of tasks, and lots of studies. So Adam is in the corner here. He did something called the Great British Intelligence Test, which was on Panorama a few years ago. And this is his most recent paper looking at long COVID, which is an international publication. And again, they invited 800,000 people and 112,000. So the participation rates are massive. So you can get a lot of people to take part. Obviously, there is always some bias. This is his tests, and if people have done his tests, they will probably remember this, maybe not liking all of them. So this is, we had 500,000 by the time we came to it, a range of tests that were options for people to try. So what we wanted to do was four things. One is to work out whether we could do this. Is it feasible? We wanted to know what was the most affected domains in MS. We wanted to then find out the best battery, because you can't do 100 tests. That's quite annoying. And then we wanted to see whether we can get a relationship between the cognitive impairment and the condition. So we did this over 4 years. So I've probably seen that we've released a number of sets of questionnaires. So initially, the first feasibility was in October 21, and we had 22 tasks. And not everybody did every task, but the idea was we could then work out by some clever analysis which task was the most important or most useful for MS. We then validated that in phase 2 in November 22, which again, about 3,000 people took part in, and we had 14 tasks. So then we did a comparative evaluation. The question is whether face-to-face is the same as online, and we did 14 tasks face-to-face and 14 tasks online, which were very similar. And then just out this year, this time is June of this year, we've done it again, which is again the 14 tasks plus 2 new tasks to see if we can get further information. So the phase 1 results told us we got 3,000 people took part, which was amazing. Lots of participation, lots of completion. So, and in fact, 17% of people had never done one before. So it was actually really good that people had started to take part. So it seems feasible. This is the results. This is a little bit complicated. I'm not going to go too much detail, but basically the green line is what normal people controls perform as, and we can see some tests show that people are, so accuracy is less, so they're less accurate on certain tasks compared to controls, but they're certainly a little bit better on some actually about it, but not all tasks. So we see that, and then the response time is how long people take to do these things. Again, if you're not as good, you're slower, so it's longer. So certain tasks, such as the trail making tasks, were very sensitive to MS about it. So therefore, it seems to be sensitive to MS. And then when we took this was actually finding the best battery. So we started with 22 and we refined that down to 12 tasks, and they cover various aspects of MS. So motor control, memory, verbal analogies, and cards. So these are little tests that gives us different abilities. So we're measuring different parts of people's cognition. And we tried to choose them so they were sensitive to MS. We didn't do too much of the same tasks, and they weren't affected by the device. Obviously, people's device that they do the tasks makes a difference. Again, this is type 2, where we saw that there was an association with, so what we call information processing speed and general performance was affected in MS. So we could pick up, and that was by disease subtype and also by length of the MS itself. So we can see that certain parts of the cognitive performance are affected, particularly in MS. Information processing speed has always been something people have focused on. So therefore, it appears valid. So this was Elisa from Sardinia did this, where she took much smaller numbers. But what we showed is that when you measure people in a face-to-face environment and then you measure them online, we can pick up about 80% of the people. So it seems to be pretty good at picking up people, but there is a difference. So an online test is not the same as a face-to-face test. So there are certainly differences between them, but we can get a general measure of your cognition from the online environment. So then we came back to you just to tell us what we've been doing. So again, I don't know how well this worked. We tried to give you feedback to how well you've done this. This is still work in progress and what's the most appropriate way of doing this. These were called spider plots, which showed how you did relevant to other people with MS or to controls you could choose. And this was one of these maps that we got of what people felt about it. So obviously, people seemed to think it was quite good, but obviously they did it. The trouble is with cognitive testing as a clinician is that some people do find it quite annoying because you always fail at it. But that's the point of the testing, unfortunately. And then just to go on what we did with your data. So this is just in, under review at the moment in Nature Communications. Essentially, we did what's called a cluster analysis, which is a type of machine learning to find that there are different types of MS, to reclassify MS. And there are certain people who have what we've always thought, but they have cognitive changes, but minimal motor changes. So this is where cognition is the main problem, but probably people are not caught or captured under the current system, and we need to think about this. So this gives us an access to maybe MS early on in a majority of cases, but there are certain people who get this differential impact. So there's one set of people who get no more cognitive problems, some people get more motor problems and very little cognitive problems, and then we get mixes of in-betweens. So this is just to show that we can starting to use these novel new techniques to try and understand about MS in a different way and think about it rather than relapsing remitting, just to think about how we're going to target this condition. So just to come on to some of the work we've done with NICE. So NICE are interested in real world evidence. So they've obviously used to use what we call randomized controlled trials, which are trials comparing one drug with a placebo or no treatment. But the trouble is they're not always available. They're not always the standard of care. And also then they can be inappropriate in certain environments. So in situations such as cancer, they're using what we call single arm trials with historical controls. But the thing is that all these approaches don't really work without understanding how people are in real life. So they asked us just recently to give us some data for one of their appraisals, which is, I can't really understand all this, and I'm sure no one, these are multi-state models to try and look into health economics to see how people are worsening over time and how treatments work. But essentially, your data, this is all anonymous. Obviously, this goes in towards the national framework to try and make decisions over treatments. So just in conclusion, I'd just like to say digital monitoring is feasible. It's practical. We're doing it. You've done it. It's really is working. The PROs, the patient-reported outcomes, are getting more valid, more validity. The idea ultimately would be, could we run a trial online or help do that, which is what we're working towards. And Jeremy will talk about Octopus later. New types of data, such as cognition, are functional. They're actually not patient, they're actual functional assessments online, and we're learning something that we didn't know before because of it. The length of the data collection, like 13 years, means that we can really see what MS is doing in the UK. So it really makes us relevant to health technologies, and we're sort of able to support and involve trial designs. So I'd just like to say thank you to all of you, actually, for taking part, and so we're very grateful for your data and then all these other people who have helped. Thank you.
Thank you, Richard. That's a really good overview, hopefully that shows the sort of breadth of data that we have available now and how it's being used as well. So next, we're going to introduce Professor Jeremy Chataway, who's going to talk about optimal clinical trials platform for progressive multiple sclerosis.
Perfect, and thank you very much indeed for asking me to present today. It's a great pleasure, great privilege, and immediately to thank the MS Register for all the work they do in supporting recruitment and focused recruitment into this trial. And what I want to do is just give you some principles of this so-called multi-arm, multi-stage trial, this big trial, which is entirely funded by the UK MS Society, for which I give thanks, and to let you know how it's all going. So Octopus, you can see what it stands for there. It's a platform. That means it's, if you like, something that we can build on and we can adapt. And it's focused on progressive multiple sclerosis, which is, of course, one of the major unmet needs in multiple sclerosis treatment. And the next slide, Rod. So if you think what we're trying to do in multiple sclerosis, this is, I think, quite a useful cartoon. We have relapsing remitting, we have secondary progressive, we have primary progressive. Of course, you could merge those together. But what we're trying to do is to reduce relapse activity and MRI activity. And we've been successful broadly with that over the last couple of decades and with increasingly potent treatments. And then what we'd like to do, secondly, is reduce that gradient of progression, reduce it and ideally flatten it. And then ultimately is that third stage to reverse it so that we can repair and regenerate and remyelinate. So these are the three axes of what we're trying to do in progressive multiple sclerosis treatment. And so we've been successful generally on the first, but we've been less successful and where we need to really work, I think, increasingly hard, as we do, in reducing that gradient of progression. And the next slide. So this is a paper which just illustrates the different mechanisms at play. So on the left, which I've not circled, are all the inflammatory responses, where broadly speaking, we've achieved some success. But that's really only half the story. And on the right are illustrations of the sorts of biochemistry, if you like, which changes in the progressive part of multiple sclerosis. For example, the energy organelles, the mitochondria, are not working 100%. There's influx from different toxic chemicals, for example, calcium and iron, and then that damages the myelin predominantly, and then maybe failure or incomplete remyelination, and then we have more direct damage on the axons, as well as many other processes. And this is a dynamic system that, of course, changes, but goes on for many years. And I think that's, of course, really illustrates the problem of what we're trying to do. We're trying to make an impact on something, but we can't sort of get hold of it, if you like, because, of course, we can't take samples like we could, for example, if someone has a liver problem or someone has a lymph node problem, we could take samples. But clearly in the central nervous system, the brain and the spinal cord, we can't take samples. So we proxy it, for example, by some MRI measures, or hopefully one day by more blood test biofluid markers. And I think that really is kind of at the core difficulty of what we're trying to do. We're trying to influence a variety and many processes which change over time. And I think, in my mind, eventually we'll have people who have developed multiple sclerosis on a number of treatments at any one time to try and have an effect on a number of processes which are contributing to this progressive biology, if you like. And the next slide. So if we think now, we kind of move the slide before, if we now think about clinical trials and maybe stand back in clinical trials, what are they? What are they? How do we know that anything works? And generally the principles are that we have people who are on a standard of care, which may be something, it may be nothing. And then we're going to divide, generally on a 50-50 basis, by a computer. So they are randomized to avoid any bias, of half the people to stay on with the standard of care and half to stay on the standard of care, but adding in that new treatment. And we call these, in this diagram, T1, 2, 3, and 4. And then you would run that, and at a certain time point, you would do a comparison on an outcome of interest, which could be MRI, or it could be cognition, as we've heard, or it could be walking. And are things the same broadly, or has there been a difference? Has there been an improvement? And of course, what we're trying to look for is an improvement if we add in a new treatment to the standard of care. And that's the, if you like, the nuts and the bolts of what we're trying to do. And then you may have heard of different phases of trial. So phase 0 is really the experimental animal work. Phase 1 is you try your treatment in a small number of human beings, maybe normal volunteers, or a small number with the condition, just to make sure there's no toxic effects that you didn't anticipate. And then you start to move and multiply out the number of people from a few dozen to a few hundred, which might be your phase 2, where perhaps you're looking at a marker of interest, for example, MRI, and then eventually build to phase 3, where you're looking at, of course, what counts, which is progression of disability, however you're measuring it. So these are the different phases of trial. And the problem is that these all take many, many years, and they are very expensive. And so the traditional approach here, you can see on the left, is to do things one by one. And the problem is the white spaces are, as I said, some years, and the years go by. Whereas, of course, we want to get new treatments or improved treatments as quickly as possible to people suffering the condition. And so on the right is the so-called multi-arm, multi-stage approach, where really you concertina everything under one platform, so that people are randomized in this diagram to the standard of care, the control, or the control with T1 or T2 or T3 or T4. Have a number of bites of the cherry, then you run that race, have a look, and see if it's worth carrying on with the medication or not. And then you can add in new treatments. And that's really the principles, the essential schematic of a multi-arm, multi-stage trial. And that has the ability, which is, I think, self-evident, to be more efficient and quicker and sort of get some answers as quick as possible. Because unfortunately, in the trial world, each section, there's quite a substantial failure rate, mainly, or perhaps because we don't fully understand the biology of what we're doing. But we have to do things in parallel, make experimental progress and make translational progress. So if I move to the next slide, you can see I've illustrated that horizontally here, where again, the computer has randomized people. Everyone is on the best standard of care, which can change during trial if they're new best standard of care, to staying on that or adding in different treatments. And then there are different analyses as one goes through, and then treatments can be dropped or added in. And so the next slide, you probably can't see this, but really one of our, really what's our inspirations for this trial, the Octopus trial, is what's called the Stampede trial, led by my colleague, Professor Max Palmer at the MRC Clinical Trials Unit, where he focused on prostate cancer in men, where there's been very little advance in what's called metastatic prostate cancer. And even if you stand back and look at this, you can see on the left how people have started off on a number of arms, and they carry on, some stop, and then more and more arms are added. And this has been going for about 25 years. And if we click on the next slide button, and we carry on, and the next button, and we carry on, you can see that here about 12,000 people have eventually taken part in the Stampede trial. And whereas there were no change in standard of care actually for about 40 years, now there have been 6 changes in standard of care, which is a kind of amazing success rate. And so we've taken this idea from the oncology cancer literature and then moved it into the multiple sclerosis area. This actually was used very recently in the COVID pandemic in what's called the recovery trial, where the UK actually had an outstanding record in putting people into clinical trial to very quickly try and work out if a medicine for COVID could be useful or not useful. And that's, for example, how we produce dexamethasone, a very simple steroid, as being very useful in COVID. And we have a really excellence in doing these sort of multi-arm, multi-stage platform trials. Of course, in COVID, first it was a public health emergency, but also there was a very quick outcome after about a month, and tens of thousands of people took place. So that's an example on one side of an acute MAMS, multi-arm, multi-stage trial, and then we see here prostate cancer. So then we want to take the inspiration and move this into progressive multiple sclerosis. And I'll show you what happened next. And we'll take the next slide. So an important principle is that you want to sort of measure something quickly that has some relationship to the final outcome. And as I'll show you, the thing we're measuring quickly is the MRI scan, because it has a relation to the later final outcome, disability. And so you need that. It doesn't have to be exact. The closer you are, actually, the smaller the number of patients you need. But if you can influence the MRI scan, there's a good chance you can have an effect on the disability. Never 100%, as I've said, but there's a good chance. And the next slide. And so what we do as the primary, what we call interim outcome in Octopus, is we look at people's MRI scans. So all of our brains are shrinking. They shrink a little bit more in progressive multiple sclerosis, and you can measure that. So here is a scan of someone with secondary progressive multiple sclerosis, and they've lost in red that brain tissue over 2 years. And so if you can measure it, then you can work out if your medication has reduced that rate of change. And that's what we have as the interim outcome, the major interim outcome in the Octopus trial. It doesn't have to be everything, and we're certainly looking right now as augmenting it with the clinical reported outcomes, say the EDSS scale, and patient-reported outcomes such as the MSIS-29. And perhaps one day we'd like to get to biofluid markers, blood tests that could augment it as well. So it doesn't have to be confined to that, but that's our sort of principal outcome. And the next slide. So again, let's now drill down to Octopus. How do these multi-arm, multi-stage schemes look for Octopus? Well, we started out by randomizing people. Everyone is on best standard of care to either the dummy drug, or the treatment 1, or the treatment 2. And as I'll show you now, we've completed that first stage, and now we just carry on randomizing. And I'll see the next slide. So this is where we wrote up, as it were, scientifically, the calculations behind this trial, the Octopus trial. And the next slide. So of course, what you need is engine, is petrol for the car, or oil for the car. And you've got to choose your best picks when you're starting out. So we spent a lot of time looking around the literature and around the scientific literature as to what molecules could have an effect on progressive multiple sclerosis. Now, we were particularly interested in repurposed drugs. So that's drugs which are used for other medications, other indications, but could have an effect in progressive multiple sclerosis. And the reason is because all of that early phase work, the animal work, the toxicology work, has been done already, and you can get a running start at it. And certainly as an academic unit, clinical unit, we wouldn't have the capability to take a brand new molecule that's never been used in humans through all these trial phases. And that's often best done by commercial organizations. But we wanted to look at medications that have been used for other things, but had a clear scientific rationale in progressive multiple sclerosis. And so we spent a number of years doing that. And the first molecule we put into trial is what's called alpha lipoic acid, or ALA. And these are some illustrations from the experimental work as to what it can do in the multiple sclerosis context. It's used quite widely in Germany, for example, to treat peripheral neuropathy when the nerves are affected. But we took that, and the next slide, I think, gives some more information, because there's a group in Oregon who'd spent many years working on this medication. And what they'd done was a trial where they again measured the brain shrinkage, the brain atrophy, and shown that compared to the dummy drug, so the dummy is in blue and the real is in orange, that it reduced that rate of brain change. So that seemed to be very encouraging. And in fact, they've just reported recently in abstract a second different trial, which again has shown that same effect. So we think lipoic acid could and should have that effect on brain atrophy, then that could and should have an effect on eventual disability. The next slide. The second pick was a medication called metformin. Now, this is widely used in diabetes, but it's very clear it does much more than that. And in fact, there are a number of different branches of medicine where metformin is being quite intensively studied to see if it can have an effect on protecting, and here neuroprotecting, the central nervous system. It's a simple drug, well tolerated, has been used in millions of people around the world for diabetes, and then we took it in. A lot of experimental work had been done by the Cambridge group led by Robin Franklin. And I think that illustration on the top right again shows what, I won't go into detail, but in green are the change in the brain of control studies. And on the right, there's an increased change on those with multiple sclerosis. So that, again, if you like, metformin could perhaps have an anti-aging effect. Perhaps part of progression is accelerated aging. And the next slide. So the trial itself, so we got going about a year and a half ago, really, and we've recruited well. And in fact, we finished the first stage of the trial. These figures slightly out of date, but we ended up with 384 people, which surpassed the 375 that we needed for that first stage of the trial. So those patients carry on now and remained under follow-up. And then over the last 30 days, we've now started the stage 2, which is exactly the same protocol, but without the MRI, which clearly has advantages, both in terms of organization, but also people who perhaps couldn't have an MRI are now able to come into the trial. And then we'll carry on with that recruitment in total for the next 2.5 years until we get to these large numbers of people that we need, probably 1,200, 1,400 people required. And we've decided, we've with a lot of PPI work, which has been incredibly helpful, we've made this quite a liberal criteria to come into trial. So it's both secondary and primary progressive multiple sclerosis, those that can walk, those that can't walk. So we measure a variety of different areas and really cover the full spectrum of those with progressive multiple sclerosis. And the next slide. And that really, again, is it kind of in schema. We've done the first stage. We're now into the second stage. All the time we're thinking about new treatments. If there's anything new, we'd always welcome from anyone that felt there was a good rationale for a treatment and there was good animal, experimental, and perhaps early human evidence. We'd always welcome ideas on that, because then we can research the compounds, think about it. Could there be something that we can put into trial, put into the pipeline? And we just keep that machine going on and on. And then we will have an initial look at this machine in sort of mid-2026 to see, on the basis of the MRI data, should the treatments carry on. Clearly, at that point, there are 3 main options. Unfortunately, no treatments carry on, or 1 carries on, or 2 carries on, and we will see. And the next slide. So that really kind of, I think, summarizes the timelines of where we are and where we're going. And we're pleased to report, as I said, that we've done the part in green now. We've completed stage 1, so nearly 400 people are live in this trial at the moment, but we need many more, as we've said. And the next slide. So we've set this up around the UK. So we have about 15 sites at the moment, and now we'll be joined by another up to 10 sites that won't need to do the MRI. And then, very excitingly, we will be carrying out this trial also in Australia. Professor Simon Broadley, who Richard and I actually did our PhDs with, is leading on that. He's based in Brisbane, and he obtained funding to, if you like, extend the platform into Australia, with hopefully a number of major sites in Australia. It's taken us about 12 months to go through the regulation and contracting, because, as you would guess, each country, of course, has its own rules and regulations. But we aim to ship out the medication to Adelaide early next year. And then the Australian sites will come on board slowly but surely. And that really is a very exciting development to get more validity, if you like, for this approach. So we're really, really delighted with that. And that's called the Platypus trial, of course, or Platypus platform, to Austronesianize it. And the next slide. So, as I said, PPI involving people with multiple sclerosis and their families and their carers in the trial design of these platforms is essential to us. This is a publication which is led by Emma Gray from the UK Emma Society, where we really shared the Octopus experience in designing this trial, and we very much carry on with this, and we have PPI representation on the boards and the steering groups of this trial as we go forward. And the next slide. I won't go through this, but let's just get an example of the trial schedule. It's actually not too bad once you get going. There's a baseline, a screening, and a 1 month, but then really the visits are every 6 months. And certainly, as Richard said, one day could we get to a more remote trialing? Something which has been an innovation in this trial is with this particular database, the patient-reported outcome measures, the PROMs, are sent electronically to the patient the day before the appointment, and then the participants fill it in beforehand, either at home or when they come in for visit. And that's been very good. And we've got all of these electronically delivered, and that's been a really helpful innovation. And all the time trying to make it easier, but still capturing valid measures, which the regulators do require. And the next slide. Committee structure, a variety of committees feed into this. For example, MRI, statistical. There's a large team behind this, which I think I'll just mention on the next slide. And the next slide. So, as I said, this is led out of the MRC Clinical Trials Unit, but many people doing a lot of hard work across the different parts of this. Certainly, as I said, mentioned the MS Register as being a vital part of this, and that's the primary way of signing into this trial. And then the simple questions will allow us to determine if the trial is right for the person or the person is right for the trial. And that just, again, makes it more efficient as we go through this. And the next slide. Again, to thank the different groups that are involved in this. And the next slide. Yep, that's it. Rod, back to you. Thank you very much.
Well, thank you very much, Jeremy. Fantastic to hear how things are going and the overall setup of it all. And I hope everybody enjoyed that. I think we have got a couple of minutes just for some of your questions, if you'll bear with us, and I can find the right thing to bring up. Richard, do you want to turn your camera back on as well? So, just while Richard's figuring that out, a couple of questions about Octopus, Jeremy, so I may as well come to you straight away. First one, how's the trial going to date? I think you've answered that so far fairly comprehensively. Has there been any side effects from the trial drugs?
Yeah, so all medication have side effects, and we designed an extensive sort of portfolio, and we designed the trial so that we could look carefully for any side effects. One particularly was with metformin. Some people can get gastric side effects, and certainly there have been side effects. But I think what we have found is we warn people of that. Generally, they will resolve after a few weeks. And whilst there's always a small number of people who cannot tolerate the what's called the IMP, the medication, whether it be the placebo or the active drugs, and we found this not to be a major problem. But we have a full separate independent monitoring committee that looks at all the possible side effects as we go through.
Second question, I'm on the Octopus trial and I'm experiencing pain and difficulty swallowing the excessively large capsules, which are larger than usual capsules, despite drinking plenty of water. I wish to remain in the study, but this is a daily difficulty. Is there any other option? Is anyone else finding this difficult?
Yeah, so the reason for the over-encapsulation is the blinding, so that you can't tell if you're on the real medication or the dummy medication, so that we don't introduce bias. And so we spent a lot of time with the company that does the over-encapsulation looking at the different sizes. And unfortunately, this was the smallest, although it's quite large, capsule that could contain the dummy or the lipoic acid or the metformin. And I've had occasional people saying that, so I am very sorry about it. Unfortunately, there's nothing we can do about it. And I'd ask you just to be patient and try and develop your own strategies to swallow it down so that you can get the medication. Clearly, if it becomes impossible, we understand that you'd have to stop the medication, but hopefully very much stay in trial so that we can monitor you in the way that we had. But just the way the manufacturers produce metformin and lipoic acid, this was the smallest over-encapsulation that we could come up with.
Thank you for that. Richard, turning to you, is research being done to find out why some people with RRMS do not go in to get progressive MS or suffer major deteriorations in symptoms to try and find out why they've been so lucky?
Well, I think definitely that's one of our key aims. I mean, we're doing a lot of research, as I say, this is as a general research. We also research in the tissue bank, looking at why people have done well as well. And that gives us candidates, which we then will take forward and feed into Jeremy's work to try and get something that we can test. So I think that is a fundamental that we're trying to do. I mean, I think obviously there are standard disease-modifying treatments available, which are getting better, which are certainly being used more, and we're certainly seeing people doing better in general. But the thing about MS is there's always differences, and that's the thing. You learn from those people who don't quite respond typically.
Sort of a follow-on question for that about, do you feel that the path of research in MS is changing? Where is the focus moving to now?
So I think it's definitely changing. I think Jeremy's, we have treatments that we call for relapsing MS, and we have standard treatments that are getting increasingly effective, but they're not capturing everything. And I think there's no question of that. And so what Jeremy's illustrating is that progressive MS is a key element that we haven't really captured that well. We're also now looking with the MS Society at early, very, very early. So with this idea of looking at cognition, we can find an element of MS that may be there before the condition is recognized. So we're actually looking at relatives and other people early on. And one of the things of the strategy of what Jeremy's said is that actually, if you did find a disease condition treatment that helped progression, if it was tolerable, you should take it from day one almost with your other treatments about that. But obviously that's tolerance, and there's another elements, but that's where we would ideally like to move to, and try and stop all elements of the condition coming forward, getting worse. I think one of the things we learned from the pathology is that there's lots of different types of pathology going on at the same time. So possibly one form of attack isn't going to be enough. You need to attack probably at multiple strands early to stop that evolving?
That kind of leads into the first question for me, really, is that how does information gathered by people with MS on the register help with the care of all people with MS? And I think you've both answered that, really. You know, collecting all this information allows us to carry out research in lots of different ways, specifically looking at treatment, helping with clinical trials, being able to monitor the disease better using patient-reported outcomes and novel measures like cognition and things like that. It all adds overall to the knowledge that we have about the disease, and that can only be a good thing for all researchers involved, really. So thank you both for answering my question for me. I have one that you're probably better qualified to answer than I am, but I'm going to have a stab. Why do the registers still use EDSS when people feel it's an inaccurate measure of their own ability? So my take on that is it's because what's used in most clinical trials to assess the efficacy of the treatment or whatever it is you're trying to chart. So everybody recognizes it's not the best, most holistic measure of the disease. It specifically focuses on a couple of aspects. But it's what we've got, and we all kind of need to do it. And I know, Jeremy, obviously some of the outcomes you're looking at in Octopus have an impact on that too.
Yeah, no, totally, Rod. I mean, in trials, we do what the regulators say, because otherwise the drug will never get to the doctor's pad, and that's just the reality. If they said it was do something else, we'd do something else. I mean, in Octopus, we have EDSS, but we do EDSS plus, so 25-foot walk, 9-hole peg test, which has also been used in some trials as primary outcome. But if you look, let's have a look at the recent trial, the Hercules trial of a BTK inhibitor. That's all done on EDSS, and that presumably will get, we would think, regulatory approval, and all the drugs that we have that. But I'm certainly not bound by it, and I'm very conscious of patient experience, and that's why we do patient-reported outcomes. I'd like them very much to come in, but at the moment, as it were, today, the regulators demand EDSS or EDSS variants.
Yeah, and one of the things we've tried to do with the register is sort of broaden that a little bit by validating a lot of the patient-reported outcomes that are out there. And, you know, Richard has certainly led on that with us and how better to apply those patient-reported outcomes. So there is more than EDSS, really.
I mean, I think that exactly, and as Jeremy says, that it's what the regulator wants, and the regulators, certainly the US and EMA, are looking at patient-reported outcomes, but there's a whole host of little things we have to do, or think boxes we need to tick for an outcome to fulfill those criteria. So I think, I mean, in Rod, you're part of an international group trying to answer, get something that is acceptable to all, and especially to regulators. So work's ongoing, definitely.
It is. Last question, because I realize we've run over by about 5 minutes. So this says, about 70% of people who live with MS are women. So why are our specific needs, i.e. menstrual periods, conception, pregnancy, IVS, breastfeeding, and menopause, so routinely passed over when it comes to collecting information on the UK MS register? I think it's a good question. And obviously we are, to a certain extent now. We have the UK MS pregnancy register. We have the menopause questionnaire that's just gone live. We've asked about pregnancy on the clinical screening forms, more or less since the register started. We could always do better. I think the focus on setting the register up was assessing the impact of treatment and effect on all people with MS. And now we've been running for 13 years. We do have the ability now to sort of turn our attention to those other factors that really do matter to people. So you could always do better, but I think that we've sort of turned in the right direction, and we recognize the importance of capturing more data. If all of you participants are willing to give us the data, is of course part of it. It's always a balance, but yeah, I think hopefully we're getting the balance more right now. And that was it. Unless Jeremy, Richard, anything else to come in on, or no?
No, nothing from me. Just to thank everyone who's interested in Octopus and for signing up, and we keep on going. So, and thank you for having me this evening.
Thank you, Jeremy. Richard?
I think that's it. We really appreciate your. It's a bit. You don't really get a reward for giving the data to us, but it's actually really starting to make a difference and be more internationally recognised and actually help move the whole field forward, which is, you know, working with other registers, large amounts of data, regulators. I mean, but these they don't come to, you know, in one day. It's a process of building towards that.
Well, thank you very much, both of you, for your excellent talks. I hope everybody enjoyed them. And thank you, everybody who came along and paid attention. This has been recorded. We will put it on our YouTube channel so other people can come and view it as well. And thank you, and I hope you have a pleasant festive period and a good evening. Thank you all.
Thank you. Bye. Bye.